Hello and welcome to the video lecture on NodeMCU Esp8266 board details. So this is a board of NodeMCU with the Wi-Fi module Esp8266 and these are the different pinouts for this board. So now we'll see one by one what are the different pins and what is the function of all the pins. Now first we will start with all the power pins which are available on this NodeMCU board. So if you can see, there are multiple power pins are available. First you can see here there is a ground and 3 volt. This is the first power pin. Second you have 3 volt and ground next to that, and there is a one more that is 3 volts and ground. So there are 3 3 volt and ground pins, and there is one V in and ground pin. So this V in and the ground pin they are used to give an external supply. That means you can give the power supply externally to this board through this V in pin. Now if you can see here, there is an micro USB adapter. So through this micro USB adapter we are going to also give the supply to the board. So actually we are not giving any external supply to this NodeMCU for the operation, but here from this micro USB cable it will be providing the 5 volt supply, and that 5 volt supply will be then dropped down to 3.3 volt, which is the requirement of the board. Now NodeMCU Esp8266 is basically an open source Lua based development board. This board is very popular for the IoT project. This is built around the Esp8266, which is a Wi-Fi system on chip. So this is an Wi-Fi system on chip, and this is what is an antenna is. And this is developed by Espressif company, and it provides a user-friendly, cost-effective way to add the Wi-Fi connectivity to the board. So that's why this is a very popular board, and this is also low-cost development board which is available. That's why this is very much popular for different IoT project. Now these 3 volt and the ground pin, which are for providing the supply to the different external devices. That means if you connect any sensors or say some other devices, then you can give the supply to that devices through this 3 volt and ground pin. Now after this you have a digital IO pins. The digital IO pins are available. So if you can see here, there are total 9 digital IO pins, that is D0 to D8. So these are digital IO. So you can connect the digital inputs and outputs to this pin. So you can see here, this is D0, D1, D2, D3, D4, D5, D6, D7 and D8. Then we have one analog pin which is called as an A0, which is for connecting analog input. So you can connect the sensor like temperature sensor or pressure sensor. So the output of that which is in the analog form, so that will be connected with this pin which is called as an A0 pin. Then this board basically supports variety of communication protocols. So the first protocol that it supports is a UART protocol, that is a universal asynchronous receiver transmission for serial communication. So here there are 2 pins, that is TX and RX pins. So these 2 pins are used for the UART communication, that is a serial communication, and actually we can interface the variety of devices like Bluetooth of RFID using these 2 serial pins, that is TX and RX. So TX stands for transmission and the RX stands for the reception purpose. Then if you can see, it also supports an SPI protocol. So if you can see, there are 6 pins which are dedicated for that. So here you can see S3, S2, S1, SC, SD and SK. So these 6 pins, they are for the SPI, that is serial peripheral interface. The 6 pins are dedicated for that. So we can connect the variety of devices using this SPI protocol. Then it also supports I2C line, that is it has a onboard I2C line. So the signals for that I2C are connected to NodeMCU. And using that I2C line, sorry, not D0 and D1, D1 and D2 lines are mainly for the I2C. And whenever you want to connect the devices like E2PROM, EEPROM or say real time clock, that is RTC, that you can connect with the help of this I2C. Okay. So these are the different pinouts which are available. Now we'll focus on the different components which are on that particular board. Now the very first component is a ESP12E chip. So this is an ESP12E chip. So the power supply required for that is in the range of 3 to 3.6 volt, and it is a Wi-Fi processor basically which is available on the board itself. Then if you can see here, this is an antenna having an frequency of 2.4 gigahertz for Wi-Fi connectivity. This is available on the board. Then here you can see this is an voltage regulator which is a 3.3 volt regulator. Now whatever voltage or whatever supply voltage you give from this USB port is actually a 5 volt. So that 5 volt supply is basically dropped down to 3.3 volt, and which will be given to the board through this regulator. So this is a 3-pin voltage regulator. Then you have a two different buttons. The one is called as a reset button and another is called as a flash button. So the flash button is used for flashing this Wi-Fi chip, and the reset button is used for resetting the entire board. Then we have seen about this micro USB port which is for powering and programming our NodeMCU. We are going to program the NodeMCU using an Arduino IDE. Then the next is you have one more IC which is called as a CH340G, which is a USB to UART TTL serial converter. So this converter basically acts as a bridge between the USB port and the microcontroller, and it enables the communication by translating the USB signals into the TTL signals which are understandable by the microcontroller. Then there is an built-in LED also available, which you can see when you power up the board to check whether your board is working fine or not. Okay, so these are the different components that are available on this NodeMCU. And finally we will go for the specifications of this board. So now let's focus on the different specifications. So the first specification of the board is it is a 32-bit processor, that is a ESP12E. The operating voltage range is 3 to 3.6 volts. Current requirement is 80 milliampere. Frequency with which it is going to work is about 80 megahertz. The flash memory which is available in the board is up to 4 MB. SRAM is available which is a 64 KB. Total digital pins are 9 that we have already seen, that is D0 to D8. There is only one analog pin available which is A0 for connecting the analog sensor. There is one SPI port, there is one I2C port, there is one UART port, and the Wi-Fi protocol which is supported is IEEE 802.11b/G-N. So this is the one wire supported protocol. So these are the specifications of this NodeMCU and the complete detailed discussion about this board. So guys, if you like the video, then please don't forget to subscribe to my channel and also like and share the video with your friends. Thank you guys. Thank you so much.